Hello everybody. In today's lecture, we will see how we can sort a given list of elements using the quick sort algorithm. Quick sort algorithm follows a divide and conquer approach. What is the meaning of this divide and conquer approach? It means that we divide a problem into sub-problems and then into further sub-problems until we get a solution. So come on, let's see how we can do it.
Come, let's first understand what is the principle of quicksort. In quicksort, our main aim is to designate an element as the pivot element. Okay, so we want to designate any element as the pivot element, and then we want to arrange our array in such a way that to the left of the pivot element all the elements are smaller than the pivot element, and to the right of the pivot element all the elements which are larger than the greater than the pivot element, they must reside to the right of it. Correct? And once this is done, then we do same for the two formed partition. So say this is partition A and this is partition B. Then we perform the same process. Say this is PA. So to the left of it all the elements smaller than PA, and right of PA will hold all the elements greater than PA. Same for this partition also. We are going to take a pivot element and arrange the elements in a way that the left of PB holds all the elements which are smaller than the partition of pivot of the partition B, and right of PB holds all the elements which are greater than the pivot of the partition B. And this goes on happening recursively. There will be a pivot element. So we can see that the problem gets divided into sub-problems. And when we follow such a technique to solve any problem, then that technique is known as, sorry for the handwriting, then the technique is known as divide and conquer technique. Okay, so in quicksort we are using this divide and conquer technique. I hope the general overview of how this or why this algorithm works and how it works to achieve this particular partitioning is clear to you all. Now I'll proceed with the detailed steps of the algorithm. So I'll just erase this part. Okay, so to establish the process that I have just explained, what we'll do is we first of all take two integers. One is start, which points to the first array. So it's simple. We initialize start with 0. Okay, and this is another integer which is pointing to the last element. So we initialize n with n minus 1, which is in this case is 8. Okay, now we have to choose a pivot element. Say quicksort says that we can choose any element as the pivot element. Okay, there is no restriction upon choosing choosing which element should be the pivot. There is no restriction upon this. So you can either choose the first element as pivot. At many places you will find that the first element is taken as pivot element. Then at some places you can see the last element is taken as the pivot element. Then at some places you will see that the middle element is taken as pivot element. So it totally depends upon you. Which one do you want to take as the pivot element? You can proceed with it. Okay, so for now I am taking somehow the central element as the pivot element, which is 9 in this case, the fourth index 9, this one. Okay. So now what does the algorithm say? It says, see, if A of start is less than pivot's value, then you have to perform an increment of the start value, that is start plus plus, else do nothing. Okay. Then the other condition is, if A of end is greater than pivot, then perform end minus minus, else do nothing. Okay. And at the end, when both these values stop moving, when both the values stop moving, then we have to perform a swap between A of start and A of end. Okay. To better understand this algorithm, we'll just do it here and see how it actually works. So as per the discussed algorithm, we check the value of A of start with the value of pivot. Correct? And this condition must be satisfied. So what is A of start here? Right now my start is 0, so A of start is 7 and my pivot element is 9. So I see that A of start is less than the pivot value. Therefore we are going to perform a start plus plus. So instead of this, see, now my start points to the next element. Okay. Now after we do this, we are going to also check the end value. So once you are going to check the start value with the pivot, and the next time you are going to check the end value with the pivot. Okay. Or you can just finish off with the start value and then you can predict the end value. That is okay. You can start off with the end value. So again, what is my A of start? It is 6. My pivot is 9. So this condition is again satisfied. So if it is satisfied, then we increment the value of start. So now my start is pointing to element 10. So again I check this condition. Is 10 less than 9? No. This condition doesn't satisfy. So if the condition doesn't satisfy, we are just going to stop here and we are going to do nothing. Then we are going to go to the end variable. We check. What we had to check? Whether A of end is greater than pivot or not. So your A of end is now 7. Is it greater than 9? No. Since it is not greater than the pivot value, therefore we are not going to decrement the value. Instead, we are simply going to stop here. Now, as soon as you stop, means as soon as you stop moving the start pointer and you stop moving the end pointer. Now, both the pointers are fixed. They can't move. As per the given conditions, they cannot move. So, as soon as you stop moving, you have to perform a swap between A of start and A of end. Okay. So after the swap, my array should look like this. So we are going to perform a swap between the A of start and A of end. So my end was 7 and A of start is 10. So we are going to perform a swap, and now my array looks like this with 9 as the pivot element. Correct? Now see what will happen here. Now your start is pointing to the second index. Correct? We shouldn't forget this. We have left our start here. My start is pointing to a of 2 and end is pointing to a of 8. Okay. So see, now what we should do is, we'll again follow the same method. We check the condition between a of start and pivot, the same condition. So now my a of start is 7 and my pivot is 9. So I will increment this value of start. So now my start is pointing to this element. I'll again do this. So now my a of start is 5. It is less than 9. So I am going to increment the value of start to the next element. Okay. Now I check whether a of start is less than pivot. So now my a of start is 9. Is it less than the pivot value 9? No. So you basically stop here. Correct? So we are going to stop here. Then what happens? We go to the end part. So for the end, my condition was if a of end is greater than pivot, then we decrement the value of end. So my end is 10 and pivot is 9. So this holds true. So now my end gets decremented and starts pointing to the next element. Correct? So again I am going to check this. It is greater than 9. Again this value is satisfied. So we are going to decrement the value of end to point it to the previous element, which is 1. So again we check this condition and it gets evaluated as false. So now neither start will move nor end will move. So these both have fixed their values. And as soon as they fix their values, what do? We perform a swap between a of start and a of end. So after performing the swap, my array will become like this. See, this will be 1, this remains unaffected, this will be 9, this is 15 and this is 10. Okay, and my pivot element remains the same, which is 9. My pivot element, I am talking about the element, it is not the position. Okay, so wherever the pivot element moves, that place becomes my pivot. Okay, try to understand. My pivot is not at a of 4, my pivot is 9. The value is 9. So now my pivot becomes this. I have highlighted it with blue. And my start is pointing to, see, it's better if I write the index. My start was pointing at the 4th index, like this. My end was pointing at the 6th index. So again I will check the same conditions, that whether a of start is less than pivot or not. So my a of start again here is 1, it is less than 9, condition satisfied. So we are going to increment the value of start, and now the start points to the next element here. Again we check this. So now my a of start is 2, which is less than 9, condition satisfied. So this will start pointing to the next element, which is here. Correct? Now what will happen? We are going to check whether 9 is less than 9 or not. No. Then we basically stop here. Correct? Now once we have stopped here, we will go to the checking of the end value. So what do we check here? We check here that whether A of end is greater than the pivot or not. So my A of end is 9 and pivot is also 9, so it is not greater, so we'll stop moving it. Okay, I would like to do a correction here. See, A of start less than equal to pivot. You have to make it equal to, otherwise this is, you'll be stuck at this position. Okay, so if I make this change here, then what change do I have to make here? See, here it becomes, is 9 less than equal to 9? Yes. When it becomes yes, then I would have incremented start. Okay, so after increment, the start must be pointing to this element. So after incrementing, my start would have become 7, and now see, my end cannot move, so my end is at 6. So when this particular condition takes place, what is the condition? When start is greater than end, then we stop the algorithm for this particular phase. Okay, we are stopping this. What does stopping mean here? Stopping means that now to the left of the pivot element, all the elements are smaller to the pivot element. Is it correct? Please have a look here. Yes. And to the right of the pivot element, all the elements are greater than the pivot element. Is it correct here? Yes. Now you can see our whole problem space is divided into two problems, as I have already discussed, that now this becomes your partition A and this will become your partition B. Now you are going to perform the same steps with only this much of the array and simultaneously with this much of the array. And again you are going to find out one pivot. Say you take 5 as your pivot for this partition. You might take up 15 as the pivot for this partition, and then you are going to again perform all these steps and divide the problem into further smaller problems. Okay, I hope you could get a view, you could visualize properly that how quicksort is going to sort the array. So after you see that you have reached this condition, as I have already told you that this is one of the stopping criteria, stopping condition. So now there is one more step after this. As soon as start becomes greater than the end, that is, you cross the end with the start, we need to perform a swap between A of end and the pivot element. Okay, you have to perform a swap. Since here the A of end and pivot are same, we are not going to do anything else. You could have seen how this swap makes a difference. Now let's look at the time complexity. See, what will be the best case of this algorithm? See, the best case would be that the pivot element is the median valued element, is the median element, we can say. So if we already pick up the median element as the pivot value, then it will take the smallest time to sort the elements less than the median value and elements greater than the median value. And as you can see, we are basically for every pivot, see at some point of time every element is going to become the pivot element. If not every, then we can say in the order of n, correct? So for n times, and the problem is getting divided into two halves, correct? Quietly resembling the structure of a binary search tree. It's not a binary search tree, it's no way a binary search tree, but you can understand that with every step of the algorithm, what is happening? After every pass, your problem gets divided into two halves. So, and it is happening for nearly all the elements. So my time complexity here will be order of n log n. Now what will be the worst case? The worst case will be you are picking up either the greatest or the smallest element as pivot. If this happens, then what will happen? Can you tell me? The time complexity of such a selection will result in order of n square. So you can see the best case is somewhat resembling the binary search tree. How I will tell you. Say, just pay attention here, this is an important one. Say I have elements from 1 to 15 and I somehow pick up the medieval element as the pivot element. So at first I will divide it into two lists where elements from 1 to 7 will be to the left of 8 and elements from 9 to 15 will be to the right of 8. Among these, if I pick the central element as the pivot, then elements from 1 to 3 will be to the left of it. Elements from 5 to 7 will be to the right of 4. Same would happen for this also. Okay. Again, among these two, if I take the median element, which is 2 as the pivot, then 1 comes here, 3 comes here, 6 I pick up as the median element, 5 comes here, 7 comes here. I pick up 10 as the median element, 9 goes here, 11 goes here. I pick up 12 as the median element, then left of 12 will be 13. I'm sorry, I have to pick up 14 here, correct? I pick up 14 as the median element, left 13 will be to the left of 14, 15 will be to the right of 14. Okay, so you can understand this will be the best case where I am getting a balanced tree sort of a structure. So the time complexity here will be n log n. Contrary to this, say I have elements from 1 to 7 and I pick up 1 as the pivot element, which is the smallest element. Then what happens? There is no element to the left of 1. Instead, you have all elements to the right, which is 2 to 7. Again, I pick up 2 as the median element here. I have only elements now only to the right of 2, which are 3 to 7. Then I have to pick up 3 as the median. So to the right of it, we have 4 to 7. So you can see what will happen. My time complexity will mount up to big O of n square. Because for every element, that is for n elements, we will have to perform the selection of pivot, putting the elements smaller to pivot to the right, putting the elements larger from the pivot to the right, which will take n time. Because see, when you are doing this, that you are picking up a pivot and then you are, first start was here, then if start is less than pivot, it goes there, yes it goes here, yes it will go here. Okay, similarly for end. So basically you are traversing around n elements. If the list is of n elements, around n elements, all the elements we are traversing here, correct? So for every element, for n elements, if you are going to do it n times, so my time complexity will be order of n square. Okay, I hope I could explain you all the nitty-gritties of quicksort. We will meet in the next lecture with another sorting algorithm. Thank you.